Okay, thanks a lot for coming on today. This is another video for ILS, and I hope you're on the right video. And this is going to talk about the periodic table and a little bit about how that works. And I think the first place I'd like you to probably be is if you go to page 26 of your packet, you'll see a periodic table. And I'm hoping you've seen one of these before in another class. If not my class, obviously, then maybe physical science or something in a different IL, or in eighth grade. So this is a periodic table, and I'm going to discuss it a little bit in just a minute, but I wanted to show you that you do have one in your packets. And the second thing I think you should have out while I talk right now is page 27, because this has an example of the periodic table with some of the important parts. And let me tell you about them. Well, first of all, you know that matter is anything that's made of mass and has space, and so air is matter, and every solid is matter. Everything is made of matter, and all matter is made up of these elements. These are called the periodic table of elements. Elements are, for example, hydrogen, are substances composed of only one kind of atom. So hydrogen is an element made of only hydrogen atoms. Oxygen is an element that's just oxygen atoms. And for example, if you put hydrogen and oxygen together, you make H2O or water, and that's called a compound. So atoms are different, and elements are different than compounds. Elements are all of the same kind of atom. Compounds are made up of two different kinds of atoms or more put together. So carbon dioxide, CO2, that's a compound. N, nitrogen, is an element made of only nitrogen atoms. And when we look at the periodic table, you can see that it has this number 1 and 2, and it comes over here, it says 13, 14, 15, 16, 17. These here are called families or groups, and they tend to share similar traits. So H, Li, Na, K, Rb, etc. He, Ne, Ar, Kr, these elements here are all called something, and they all have similar traits, and these are called groups or families. The horizontal rows going across, going like that, watch my mouse, these are called periods. So this is period 1, this is period 2, this is period 3, going across. This big long one is period 4, and 5, 6, and 7. So there's 7 total periods. Another thing that's interesting is that all of the ones, these first two groups right here, 1 and 2, these are all metals. And so I know it sounds weird for you to think about that, but sodium, when it's not with salt and sodium is actually a metal, and I can show you that. I'm going to probably show that to you at some point. Magnesium, again, it's a metal. All of the ones to the right of this staircase-looking structure here that's in black, these are called nonmetals, and the ones in the middle here are called metalloids because they're kind of like they have metal and non-metal properties to them. Some are shiny and bendable like metals are, and some have properties that are not quite so shiny and bendable and maybe don't represent as much. And so we sometimes call them transition metals or metalloids. Theoretically speaking, if you're going to be looking at the periodic table, the metalloids are usually the ones that are right next to the stairwell, and these tend to be called transition metals over here. Some people kind of refer to them all as transition metals, as transition metals, but B and Si, boron, silicon, these ones here, aluminum, beryllium, these are all these are ones along the staircase here. These are called metalloids usually, and then these tend to be called transition metals, just as a kind of vocabulary. And then at the end of the bottom of the page, I've kind of got them more laid out for you again with the names of the different groups. So this group going down, remember they're called groups or families that all have the same traits. These are called the alkali metals. These are called the alkali earth metals. I mentioned that these are called transition metals. The ones along that staircase are called metalloids, and all the ones over here are called nonmetals. So for example, oxygen is a nonmetal, and sulfur, chlorine, bromine. And then this last group all the way over here are called noble gases, and it's because of the way that their structures are drawn. And they tend to have full orbits with their electrons. You may remember from my last movie that in every atom has 2 electrons that fit in the first orbit and 8 that fit in the other 2 orbits, and in the next orbits. And so when you look at something like neon actually is a noble gas because its outermost level is full. So that means either 2 electrons if it's the first level, or up to 8. If it has 8 in the last level, then it also could be a noble gas. And we can draw these to see that too. We'll practice with that. Now, the other thing I wanted to show you, besides pages 26 and 27, is online, of course. Remind yourself that this is a nucleus with protons and neutrons making up the mass, and then going around in circles around the nucleus are these electrons. Now, this picture I just looked up online, but I will take you also back, and I want to remind you that if you go to my website and you click right over here where it says Class Material on Moodle, you will get to my Moodle site. And you'll have to sign yourself in. And one of the things that you're going to find in Unit 1 is I put on an online periodic table, and I'll tell you about the numbers in just a second. I think you know these already, though. These are called the atomic numbers. And if you click on any one of the elements, you'll get all the information that you might need to know if I was going to ask you about it. Now, of course, I'm not going to. And also, if any of you have trouble pronouncing the word, then you can click on this, and it will actually say the word for you, so you can hear it said. And so I want you to get to know the periodic table. Again, these are called groups or families going down, and these things that go across are 1, 2, 3, 4, 5, 6, and 7 going across are called periods. And one of the things that I want to teach you about a little bit is what we call periodic trends. Periodic trends are things that are kind of patterns that you notice in the periodic table. And the main one that I want to tell you about a little bit is atomic size. Let me show you this pretty cool website. Again, on Moodle. And when you click to Moodle, you know there's no login for this class, so I made it so it was open for you. And if you click on it, you'll get my Moodle site, which you've seen now a few times. But if you look over here, I've got all sorts of different links for you, including some of the other stuff you did in the other movie. And the SparkNotes website seems to be a really good website. It was recommended to me. And this tells you a little bit about the atom. And the one I really want to tell you about is a periodic pattern or trend in the periodic table. And the one I want to talk about is the size of the atom. We call that the radius, or the size of the atom. And the way it works is really pretty simple. As you go from left to right, from K, for example, all the way to KR, an atom actually, you might think it gets bigger because the number's getting bigger, but atoms actually get smaller as you go to the right. And that's because they have a lot of more, every one of these has one more proton and sometimes a couple more neutrons, and they actually attract the electrons. Pluses get attracted to the minuses, and they kind of pull the electrons in and make the atom smaller the more protons you have going this way. However, that's the atomic number. However, going downwards, they get bigger, because every time it goes down one of these periods here, one of these goes down to here, these right here end up having one more orbit or energy level of electrons, so they're actually going to be bigger. So the trend for size is that you start out big to the left and get smaller as you go to the right, but you also start smaller at the top and you get bigger as you go down. And that's called a periodic trend, and specifically we call that the periodic trend of atomic size. So this website shows you pretty good that atomic size gets smaller as you go to the right, and it gets bigger as you go down. The rest of those terms we're not really going to be talking about right now, but you're welcome to read them. And then if you go back to that main page, you're going to see a bunch of other links that might help you from our last discussion. And so that's a little bit about the periodic table, and we're going to practice some stuff in class. So I hope you guys enjoyed it. Have a great time.